Hello everyone, welcome to my channel. I am Balaji Chandrasekharan. Today I will be discussing one of the key features of Java 8, default and static methods in interface. Before Java 8, interfaces in Java could only contain method declarations, and these methods were explicitly abstract and public. Implementing classes were required to provide concrete implementations for all the methods declared in an interface. Prior to Java 8, designing interfaces can be challenging, especially when considering the potential impact on implementing classes. This was a significant concern prior to Java 8 because any addition of methods to an interface would require all classes implementing that interface to provide concrete implementations for the new methods. This could lead to a considerable maintenance overhead. The introduction of default methods in Java 8 addressed this issue by allowing interfaces to provide method implementations. With default methods, you can add new methods to an interface without breaking existing implementations. Implementing classes automatically inherit the default method and they only need to provide an implementation if they want to override the default behavior. I am giving an example of a built-in default method added in Java 8. In Java, certain interfaces in the standard library use default methods to provide additional functionality without breaking the existing implementations. For example, the iterable interface has a default method for each added in Java 8. This allows any class implementing iterable to automatically have the for each method available without requiring an update to the class. Similarly, the list interface in the java.util package has default methods like sort, replace all, etc. added in Java 8. For an example consideration, let us have the shape interface with the draw method as an abstract method and the get description method as a default method. Now, any class implementing the shape interface must provide an implementation for the draw method as it's declared as an abstract method in the interface. On the other hand, the get description method has a default implementation, meaning the classes implementing the interface are not obliged to provide their own implementation unless they choose to override it. As in this example, the circle class is implementing the shape interface. It must have to provide an implementation for the draw method but doesn't need to override the get description method, which means it inherits the default implementation of the get description method from the shape interface. The diamond problem is a term used in the context of object-oriented programming languages that support multiple inheritance such as C++ or interfaces in Java 8 and later. It arises when a class inherits from two classes that have the common ancestor. Talking about multiple inheritance is when a class, a child class inherits the properties from more than one parent and the method signature for the parents are same. That is, the method name and parameters are exactly the same. Then the child gets confused about with which method will be called. This problem in Java is called the diamond problem. Here is the simplified explanation. Consider the following class hierarchy. Class D inherits from both B and C, which in turn both inherit from A. If B and C have a method with the same name and D does not override that method, it creates ambiguity. The question is which implementation should be used. The ambiguity is referred to as the diamond problem because The inheritance structure forms the diamond shape in the class hierarchy. In languages like C++, where classes can have concrete implementations, this problem can lead to unexpected behavior. However, in Java, the problem is mitigated by the fact that the interfaces can have only declare methods, not provide implementations prior to Java 8. Java's approach to interface default methods conflict resolution helps mitigate the diamond problem by providing clear rules on method precedence and requiring explicit resolution when conflicts arise. I defined some interfaces for different aspects of a shape, such as drawable, resizable. Here is a simple example. In this example, circle implements drawable and resizable interfaces, providing concrete implementation for the methods declared in each interface. Both drawable and resizable interfaces have a default method getDescription. The circle class implements both interfaces and provides specific implementations for draw and resize. It also overrides the getDescription method to provide a specific description for a circle. If we remove the getDescription method in circle class, we will get the compilation issue like duplicate default methods named getDescription with the parameters are inherited from the types resizable and drawable. When a class implements two interfaces that both declare default methods with the same name and signature, it creates a conflict. The class must explicitly provide an implementation for that method to resolve the conflict. This is to avoid ambiguity and ensure clarity in the inheritance hierarchy. This approach ensures that the class explicitly chooses which default method implementation to use or provides its own custom implementation when there is a conflict. In Java 8 and later versions, interfaces can have static methods. Static methods in interfaces provide a way to organize utility methods later to the interface without requiring an instance of the interface. These methods are associated with the interface itself, not with any specific instance. When calling a static method from an interface, you need to use the interface name to proceed with the method name. This syntax distinguishes static methods in interfaces from instance method. This syntax ensures clarity and emphasizes that the method is associated with the interface itself, not with the instance of classes implementing the interface. It is a key aspect of the design to make the invocation of static methods in interfaces explicit and unambiguous. In Java 8 and later versions, several built-in interfaces in the Java standard library use static methods to provide utility functions. Here are a few examples. The collection class provides static methods for working with collections such as sorting, searching, and creating unmodifiable views. The math class contains static methods for performing mathematical operations. The files class has static methods for working with files and directories. These are just a few examples, and there are many other classes in the Java standard library that use static methods in interfaces to provide utility functionality. This approach allows for a more organized and modular design, grouping later to methods with a common interface. To understand how static methods work in interfaces, let us refactor the vehicle interface and add a static utility method to it. Defining a static method within an interface is identical to defining one in a class. Moreover, a static method can be invoked within other static and default methods. Let us suppose that we want to calculate the horsepower of a given vehicle's engine. We just call the get horsepower method. The idea behind the static interface methods is to provide a simple mechanism that allows us to increase the degree of cohesion of a design by putting together related methods in one single place without having to create an object. The same can pretty must be done with an abstract class. The main difference is that the abstract class can have constructor, state, and behavior. Moreover, the static methods in interfaces make it possible to group later utility methods without having to create artificial utility classes, which are simply placeholders for static methods. To summarize some key features introduced in Java later to interfaces, Java 8 introduced the concept of default methods in interfaces. This allows interfaces to have methods with implementation. The feature was primarily introduced for backward compatibility, allowing interfaces to evolve over time without breaking existing implementations. Similar to classes, interfaces can now have static methods in Java 8 later. These methods are associated with the interface itself, not with any instance of the interface. Default methods in interface were indeed introduced to address the issue of backward compatibility. They provide a way to add new methods to interfaces without forcing the implementing classes to provide an implementation. Existing classes that implement the interface automatically inherit the default method. The introduction of default methods in interfaces helps address issues related to the diamond problem. When a class implements multiple interfaces that have the default methods with the same name and signature, the class must provide an explicit implementation, resolving potential conflicts. These features explicitly enhance the flexibility and functionality of interfaces in Java, allowing for more expressive and extensible designs. Thanks for watching my video.